As we drift silently through the cosmic tapestry, let's turn our gaze beyond the familiar stars and galaxies that twinkle around us. For a long time, humanity believed our universe, this immense, sprawling collection of stars, planets, and galaxies, was all there was, a single, grand stage for all of existence. But what if that's not the whole story? What if our universe, as vast and incomprehensibly large as it is just one small part of something even grander? Welcome to the fascinating, mind-bending idea of the multiverse. Imagine for a moment, not just the billions of galaxies we can see, stretching out further than our most powerful telescopes can reach. Imagine something even bigger, something that encompasses not just our single universe, but countless others, perhaps different in ways we can barely conceive. It's a truly wild thought, isn't it? Like finding out your small hometown is just one house on an infinitely sprawling planet, which itself is just one planet in an endless cosmic neighborhood. If you like listening to quiet stories about space and stars, please tap the like button. It helps others find this peaceful place too. And if you want to come back for more calm journeys through the universe, please like and subscribe. Enjoy what I do here, and let me know in the comments where you're tuning in from and what time it is for you. It's always fascinating to see who's joining us from around the world. Let's start our journey into this possibility by thinking about our own universe, the one we call home. When astronomers talk about the universe, they often mean the observable universe. Now, what does that mean? Well, light travels at a certain speed, a cosmic speed limit. And since the universe began, roughly 13.8 billion years ago, light from very distant objects has only had so much time to reach us. So, the observable universe is like a gigantic bubble around us, containing everything whose light has had enough time to arrive at our eyes or our telescopes. Anything beyond that bubble, no matter how much more is out there, is simply too far for its light to have reached us yet. It's like standing in a vast, dense fog. You can only see so far, but you know the fog continues much further beyond your sight. So, the first, and perhaps simplest, idea of a multiverse comes from just assuming that our universe is much, much larger than our observable bubble, perhaps even truly infinite. Imagine, if you will, that the fabric of space just goes on, endlessly. If that's the case, then things get really interesting. Think about it. If space is truly infinite, and matter and energy are spread throughout it in every possible way, then eventually, everything that can happen will happen. Not just once, but an infinite number of times. Picture this with me. Imagine you are floating in this truly infinite universe. Far, far away, beyond billions upon billions of light years, there might be another galaxy exactly like our Milky Way. And in that galaxy, there might be a planet exactly like Earth. And on that planet, there could be a person exactly like you, reading this exact script, experiencing this very moment. If the universe is infinite, then any arrangement of atoms, any sequence of events, will eventually repeat. Not just once, but an endless number of times, simply because there are an infinite number of places for it to happen. It's like drawing numbers. If you have an infinite supply of paper and pencils, and you keep drawing random numbers, eventually you'll draw the same number again, and again, and again. In this kind of multiverse, these are not separate universes in the sense of being disconnected from ours. They are just incredibly, impossibly far away regions within the same continuous, infinite universe. We can't see them, we can't reach them, but mathematically, if space is endless, they must exist. Now, as we ponder this dizzying thought, imagine the tiny variations. In one of these impossibly distant Earths, perhaps your coffee cup is blue instead of red. In another, you chose to wear a different colored shirt this morning. And in still others, vast differences unfold. Perhaps dinosaurs never died out, or humans developed wings. If the universe is infinite, every single tiny decision you could have made, every path your life could have taken, might be playing out somewhere, on another Earth, incredibly far away in this same boundless cosmos. It's a strange kind of multiverse, almost a philosophical one. It doesn't require any fancy physics beyond the idea of an infinite space, which is already a pretty big leap of imagination. But it immediately brings up profound questions about what it means for something to be unique, or what it means for you to be you. If there are infinite copies of you out there, are any of them truly you? This Level 1 multiverse, as some scientists call it, is simply a consequence of an infinite universe. It's a vast cosmic canvas where every single possibility, no matter how small or how grand, is painted somewhere, an infinite number of times. Now, let's take an even bolder leap into the unknown. Imagine not just an infinite expanse of our universe, but an infinite number of different universes, each with its own unique set of rules, its own distinct cosmic story. This brings us to what some call the Level 2 multiverse, often born from a fascinating idea called eternal inflation. To picture this, let's cast our minds back to the very beginning of our own universe. Scientists believe that right after the Big Bang, our tiny infant universe went through a super-fast growth spurt called inflation. Imagine blowing up a balloon, but at an incredibly, impossibly rapid rate, faster than anything we can truly comprehend. This cosmic inflation stretched the tiny, quantum jitters of the very early universe into the vast, smooth cosmos we see today. Now, here's where the multiverse idea comes in. What if this inflation didn't just happen once, to create our universe, but is still happening, eternally, in a much larger, overarching space? Imagine this grand, inflating space as a bubbling foam. Within this foam, individual bubbles occasionally stop inflating, cool down, and form their own distinct universes, much like ours. Our universe, then, would be just one such bubble, a cozy pocket where inflation stopped, allowing stars and galaxies to form. But outside our bubble, the eternal inflation continues, constantly spawning new bubbles, new universes, forever. Think of it like this. Imagine an endless ocean, constantly boiling and frothing. Every now and then, a little bubble of steam might break away from the main surface, rise up, and become its own distinct tiny world in the air, complete with its own internal weather and atmosphere. In this analogy, our universe is just one of those tiny steam bubbles, floating in an infinitely vast and eternally boiling cosmic ocean. The truly mind-bending part of this bubble multiverse is that each of these newly formed universes might be incredibly different from ours. When a new bubble pinches off and stops inflating, it might end up with different fundamental physical laws. Imagine if gravity were weaker or stronger, or if light traveled at a different speed. What if the basic particles that make up everything were different? What if the very fabric of space had a different number of dimensions, beyond our familiar 3 spatial dimensions? In some of these bubble universes, stars might never form because gravity isn't strong enough to pull matter together. In others, stars might burn out instantly because nuclear forces are too powerful. Imagine universes where light doesn't exist, or where time flows backward. Most of these universes would be utterly barren, strange, and fundamentally unlike anything we could imagine supporting life. This idea of a Level 2 multiverse helps scientists tackle a big question about our own universe. Why do its physical laws and constants seem so incredibly just right for life to exist? It's like finding yourself in a room where every single dial and setting on a massive control panel is perfectly adjusted to allow you to breathe, see, and thrive. If gravity was slightly stronger, stars would burn out too quickly. If the force holding atomic nuclei together was slightly weaker, carbon wouldn't form. It all seems incredibly finely tuned. In a Level 2 multiverse, the answer might be simple. It's just a matter of chance. If there are infinitely many universes, each with randomly different physical laws, then it's not surprising that at least one of them, like ours, would happen to have the perfect conditions for life to emerge. We simply find ourselves in this particular universe because it's the only kind where we could exist. It's like a cosmic lottery, and we won the grand prize of existence, but only because an infinite number of tickets were sold, covering every possible combination. This concept paints a picture of creation that is ongoing, never-ending, and incredibly diverse. It suggests that the universe we know is just a tiny, unique pocket in a much grander, continuously unfolding cosmic reality. It's a leap from simply being far away to being fundamentally different, opening up a whole new realm of possibilities for what existence truly means. Now, let's dive into an even more mind-boggling idea, one that doesn't just involve space stretching out or new universes bubbling off, but one that suggests our reality itself is constantly splitting. This is the Level 3 multiverse, and it comes from the strange, almost magical world of quantum mechanics. Imagine for a moment that you could zoom down, past galaxies, past stars, past planets, past atoms, to the very tiniest particles that make up everything. Down at this incredibly small scale, the rules of physics are wildly different from what we experience in our everyday lives. Particles don't behave like tiny billiard balls. They behave in incredibly strange ways. For instance, a tiny particle, like an electron, can exist in multiple places at once, or be spinning in multiple directions at the same time, until it's actually observed or measured. It's like a cosmic coin spinning in the air, being both heads and tails until it lands. This is where the many worlds interpretation of quantum mechanics steps in. It suggests that every time one of these tiny particles has to decide which state to be in, or every time a random quantum event occurs, the universe doesn't just pick one outcome. Instead, the universe splits into different versions of itself, with each version representing a different possible outcome. Imagine it like this. You're at a crossroads. Do you turn left or right? In your everyday experience, you make a choice, and that's the path you take. But in the many worlds multiverse, when you make that choice, the universe itself splits. In one new universe, you turned left. In another new universe, you turned right. And this isn't just about big decisions. It happens at every single quantum event, every flicker of a photon, every decay of a tiny atom. Think of a cosmic movie that has infinite reels. Every time a character faces a choice, the movie doesn't just continue on one path. Instead, a new projector starts up, playing a new reel where the other choice was made, and then it happens again and again, forever. The number of these parallel universes stemming from this idea is truly astronomical, branching off with every single quantum possibility. So, in this multiverse, there are countless copies of you. In one parallel universe, you decided to skip breakfast this morning. In another, you had toast. In another, you had pancakes. In yet another, you're an astronaut floating through space, having made a different set of choices leading to that outcome. All these different versions of reality exist, parallel to each other, but entirely unaware of each other's existence. They split off, and their paths diverge forever. This kind of multiverse isn't about different universes being far away in space, like Level 1, or about different universes bubbling off with different physical laws, like Level 2. Instead, it's about every single moment, every single quantum possibility, leading to a new, branching reality. These universes are parallel in the most profound sense. They're all happening at the same time, but in slightly different, ever-diverging realities. It's a dizzying thought, isn't it? That every time a tiny subatomic particle makes a choice, a whole new universe is born. It challenges our very notion of what reality is. Is your reality the only reality? Or are there countless versions of you, experiencing countless versions of this very moment, all stemming from the endlessly branching possibilities of the quantum world? It certainly makes your everyday choices feel both incredibly significant and utterly insignificant at the same time. Now, prepare for what is arguably the most abstract and mind-bending leap into the multiverse. This is the Level 4 multiverse, and it suggests something truly radical, that any consistent mathematical structure is not just an abstract idea, but is a universe. Imagine for a moment that the universe isn't just described by mathematics, but that it is mathematics. Think of it like this. If you build a computer simulation of a world, and the rules of that world are entirely consistent, then that simulated world exists, at least in some sense. In the Level 4 multiverse, the idea is that if a mathematical structure is completely self-consistent, if all its rules fit together perfectly without contradiction, then that mathematical structure is a reality, a universe in its own right. This is very different from the other levels we've explored. Level 1 was about more of our universe, just stretched infinitely far. Level 2 was about universes with different physical laws, like stronger gravity or different types of particles. Level 3 was about branching realities from quantum choices. But Level 4 goes deeper, suggesting that the very framework of existence, the fundamental rules and relationships that define a universe, could be different. Imagine a universe where the concept of 3 is different, or where parallel lines do meet, or where time has more than one dimension, or where space isn't even continuous but made of discrete, tiny chunks. These aren't just universes with different physical laws within the same mathematical framework. These are universes where the fundamental mathematical rules themselves are utterly alien to us. It's like thinking of all the possible video games that could ever be designed. Each game has its own internal logic, its own rules, its own physics, its own characters, and its own goals. If a game is perfectly designed and consistent, it can be played, it can exist. In the Level 4 multiverse, every possible consistent set of mathematical rules defines a universe, and all of these universes exist in some grand, abstract metaspace of possibilities. This idea is incredibly profound because it suggests that the universe we live in is just one particular mathematical structure out of an infinite number of possible mathematical structures. We find ourselves in this universe because it's the one whose mathematical rules allow for observers like us to exist. In many other mathematically consistent universes, there might be no stars, no atoms, no consciousness, nothing recognizable to us at all. This Level 4 multiverse pushes the boundaries of what we even mean by existence. It's not something we can ever hope to travel to or even observe. It's a statement about the nature of reality itself, a bold claim that reality is fundamentally abstract and mathematical. If you can describe it mathematically, and it doesn't lead to contradictions, then it exists. Now, as you try to wrap your mind around that, consider how challenging this is to even talk about. How do you imagine a universe where the rules of arithmetic are different? It stretches our brains to their absolute limits, asking us to think beyond even the most exotic forms of physics we know. It's less about different places you could visit, and more about different fundamental ways reality itself could be structured. It's the ultimate library of everything that can possibly exist, defined by pure logic and consistency. So, we've journeyed through 4 incredibly different ways to imagine a multiverse. Let's just take a moment to briefly recap them, to keep them straight in our minds as we float here in the cosmic quiet. First, we had the Level 1 multiverse, simply an infinite expanse of our universe, where everything that can happen will happen, an infinite number of times, in incredibly distant, unreachable places. It's just more of our kind of reality. Then, we explored the Level 2 multiverse, a grander, eternally inflating space, constantly bubbling off new pocket universes, each with potentially different physical laws, like gravity being stronger or light having a different speed. These are truly distinct realities. Next, we dove into the quantum weirdness of the Level 3 multiverse, the many worlds interpretation, where every tiny quantum decision or event causes the universe to split into parallel realities, creating infinite versions of ourselves, living out every possible choice. And finally, the mind-bending Level 4 multiverse, the idea that every consistent mathematical structure is a universe, suggesting that reality itself is fundamentally abstract and that our universe is just one mathematical equation out of an infinite number of possibilities. Now, it's important to remember that these levels aren't necessarily separate, isolated ideas. They can actually stack on top of each other. For instance, if the Level 2 bubble universes exist, then within each of those infinite bubbles, you could also have Level 1 repetitions. And if quantum mechanics works the way Level 3 suggests, then within each of those bubbles, and within each of those infinitely repeating regions, reality is also constantly branching. It's like a nested set of cosmic dolls, each revealing a new layer of astonishing complexity. But here's the big, quiet question that hangs in the cosmic silence. How do we know if any of this is true? How do we prove or disprove the existence of something beyond our own universe? It's a colossal challenge, isn't it? By their very nature, these other universes are incredibly difficult, if not impossible, to directly observe. We can't simply build a bigger telescope and look outside our own cosmic bubble. However, scientists are always thinking creatively, looking for subtle fingerprints or indirect evidence that a multiverse might leave behind. For instance, if our universe is just one bubble in a larger foam, perhaps it might have occasionally bumped into a neighboring bubble in the distant past. Imagine 2 cosmic soap bubbles colliding gently. Such a collision might leave a faint, telltale bruise or pattern in the oldest light of our universe, the cosmic microwave background radiation. It would be like finding a faint ripple in an ancient pond. a whisper of a distant encounter. Other ideas involve searching for strange anomalies in the distribution of galaxies, or subtle, unexpected features in the very fabric of space-time that might hint at interactions with other realities. It's a bit like being a cosmic detective, looking for the tiniest clues in the grandest crime scene imaginable, hoping to find evidence of realities beyond our own. As you ponder this quest for cosmic clues, consider what it all means for us. If there are countless universes out there, some exactly like ours, others wildly different, does it change how we view our own existence? Does it make us feel smaller, or perhaps even more unique in our particular cosmic lottery win? It pushes us to question the very nature of reality, of destiny, and of our place in an unimaginably vast tapestry of possible worlds. It transforms our understanding of everything, from a single, grand whole into an infinite collection of wonders. Let's return for a moment to that puzzling question we touched on earlier. Why does our universe seem so perfectly suited for life? This isn't just about whether there's water on a planet. It's about the fundamental dials and settings of reality itself. Imagine a cosmic control panel with many knobs. One knob controls the strength of gravity, another controls the mass of an electron, another controls the precise strength of the forces inside an atom's nucleus. If any of these knobs were even slightly different, just a tiny fraction of a hair off, our universe might be a very different, and likely barren, place. For example, if gravity were a tiny bit stronger, stars would burn through their fuel much, much faster, maybe in just a few million years. Not enough time for complex life to evolve on orbiting planets. If gravity were too weak, matter might never clump together to form stars or galaxies at all. If the exact balance of forces inside an atom's nucleus was off, complex elements like carbon, oxygen, and nitrogen, which are the building blocks of life, might never have formed. It seems almost too perfect, doesn't it? As if someone precisely calibrated the universe just for us. This leads us to what scientists call the anthropic principle. It's not a physical law, but more of a way of thinking about things. It simply states that the reason we observe the universe to be the way it is because if it were any different, we wouldn't be here to observe it. It's like finding yourself in a room and noticing that the light switch is exactly where you can reach it. Is it designed just for you? Or do you just happen to be in the room where the light switch is within reach? The multiverse offers a compelling, albeit very grand, answer to this fine-tuning puzzle. If there are truly an infinite number of universes, as in the Level 2 bubble universes idea, and each one has a random set of physical laws, then it's not surprising that at least one of them would hit the cosmic jackpot and have the exact right conditions for complex life to emerge. In this vast cosmic landscape of possibilities, our universe is simply the tiny, fortunate corner where the dials happen to be set perfectly. It suggests that our existence isn't a miraculous coincidence in a single universe, but an inevitable outcome across an infinite array of possibilities. However, this idea also sparks a huge debate in the scientific community. Some find it a powerful and elegant solution, while others argue that it's a bit like giving up on finding a deeper reason, a way to explain away the fine-tuning without actually proving other universes exist. How can we test a theory that explains everything by saying, it just happens somewhere else? It highlights the enormous challenge of working with ideas that are, by their very nature, beyond our direct observation. But even without direct observation, the idea of a multiverse continues to be a fertile ground for thought, pushing the boundaries of what we consider possible. The 4 levels we've discussed are simply the current main ways scientists categorize these ideas, born from our deepest theories about space, time, quantum particles, and mathematics. As our understanding of the universe deepens, as new theories emerge, and old ones are refined, entirely new ways to imagine a multiverse might arise. Perhaps there are even more layers, more dimensions, more possibilities that we haven't even begun to conceive. Imagine the sheer scale of the failed universes in this cosmic landscape, billions upon billions of bubble universes where gravity was too strong or too weak, universes where atoms never formed or where light faded instantly, universes that existed for a mere fraction of a second before collapsing into nothingness. If the multiverse is real, then our universe, with its twinkling stars, its vibrant galaxies, and its living, breathing planets, is truly a rare and precious jewel, amidst an almost incomprehensible sea of cosmic might-have-beens. It makes the existence of our universe, and our very presence within it, feel even more extraordinary. It makes the existence of our universe, and our very presence within it, feel even more extraordinary. Let's dwell a little longer on these cosmic dials, because there's another truly perplexing setting in our universe that makes scientists ponder the multiverse. It's tied to that mysterious force we call dark energy, the one that's causing our universe's expansion to speed up. Imagine it as a tiny, almost imperceptible push that fills all of space. Now, according to our best theories of physics, the amount of dark energy should be absolutely enormous, trillions upon trillions of times, stronger than what we actually observe. If it were that strong, the universe would have expanded so fast right after the Big Bang that matter never would have clumped together to form stars or galaxies. It would be a vast, empty, desolate space. Yet, we observe that the value of dark energy is incredibly small, just enough to gently nudge the universe's expansion, allowing galaxies to form and life to flourish. This is one of the biggest unsolved mysteries in physics, often called the cosmological constant problem. Why is this cosmic push so incredibly, unbelievably tiny? Again, the multiverse offers a potential, albeit grand, explanation. If there are countless universes, as suggested by eternal inflation, and each has a different value for this dark energy dial, then it's simply a matter of probability. Most universes would have huge amounts of dark energy, leading to an empty, lifeless cosmos. But a tiny fraction of them would happen to have this incredibly small, just right value, allowing for stars and galaxies and us. We just happen to find ourselves in one of those rare, hospitable universes because, well, we couldn't exist in any of the others. It's the anthropic principle again, playing out on an even grander stage, involving the very destiny of the universe's expansion. It's a concept that forces us to confront our own observer bias. We can only observe a universe that is compatible with our existence. This doesn't mean the universe was created for us, but rather that our existence is contingent upon the universe having certain properties. If the conditions were different, we wouldn't be here to ask questions about it. It's a subtle but profound shift in perspective, moving from a view of the universe as a unique, perfectly tailored home, to one where our home is merely one among an infinite range of possibilities. Now, wrapping our minds around truly infinite numbers, or grasping the concept of universes where mathematics itself is different, pushes us to the very limits of human comprehension. Our brains evolved to navigate a small, three-dimensional world, not to conceptualize an endless array of realities or dimensions beyond our perception. It's like trying to imagine a color you've never seen, or a sound you've never heard. These multiverse ideas force us to expand our mental horizons in ways that are both exhilarating and humbling. And the ideas of a multiverse aren't just floating out there in isolation. They often arise from our deepest and most cutting-edge theories about how the universe works, theories that go beyond our current standard models of particle physics and cosmology. Concepts like string theory, which proposes that the fundamental particles are not tiny points but tiny vibrating strings, or loop quantum gravity, which tries to unite gravity with quantum mechanics, often hint at the possibility of extra dimensions or multiple realities. These complex theories, while challenging to explain simply, often open up theoretical doorways to various forms of the multiverse, making them a natural, if not inevitable, consequence of our attempts to build a unified understanding of everything. Despite the fact that direct proof of the multiverse remains elusive, the very idea holds an incredible allure for many scientists and thinkers. It's not just about finding answers, it's about the sheer wonder of the unknown. It offers a solution to some of the universe's deepest puzzles, and it vastly expands our understanding of what reality could be. It pushes the boundaries of our imagination and keeps us looking for clues, always wondering what lies beyond the edges of our perception. Now, as we float here in the quiet cosmic expanse, let's circle back to those potential fingerprints of a multiverse. Remember that faint, ancient glow we talked about earlier, the cosmic microwave background radiation? It's like the very first light in the universe, a fossilized glow from when the cosmos was just a baby, only 380 years old. This light is incredibly uniform, almost perfectly smooth, telling us that the early universe was very much the same everywhere. However, When scientists look at this ancient light with extreme precision, they find tiny, tiny temperature variations. These tiny bumps and dips in temperature eventually grew into the vast galaxies and clusters of galaxies we see today. But there's one particular area in the cosmic microwave background that's a bit of an enigma, a surprisingly large cold spot. It's a region that's significantly colder than the average, much colder than our current theories predict. It's a bit like finding a very deep, unexpected dimple on an otherwise smooth, perfectly round ball. Now, some very adventurous scientists have speculatively suggested that this cold spot might, just might, be a subtle scar left by our universe's ancient collision with another bubble universe. Imagine if our infant universe, as it was inflating, gently brushed up against a neighboring bubble. Such a cosmic fender bender could have left a cool imprint, a faint bruise, on our cosmic microwave background. It's a highly speculative idea, a cosmic whisper rather than a shout of proof, but it's one of the most intriguing potential clues we have that our universe might not be alone. Beyond light, scientists are also hoping to use other cosmic messengers to search for signs of a multiverse. Remember those ripples in space-time called gravitational waves? We've successfully detected them from colliding black holes and neutron stars. In the distant future, perhaps even more sensitive gravitational wave observatories might be able to pick up extremely faint echoes from the very early universe, or even from the interactions of different bubble universes. Imagine listening to the universe and hearing a faint, distant hum that doesn't quite fit, a vibration that suggests something beyond our own reality. This would be incredibly difficult, like trying to hear a tiny pebble drop into a pond from across an entire continent, but the possibilities are tantalizing. And sometimes, the idea of a multiverse isn't about entirely separate bubble universes. It's about other realities that might exist in extra dimensions, beyond our familiar 3 dimensions of space. Imagine a sheet of paper. We live on that sheet, moving left, right, forward, and backward. But what if there's another sheet of paper, a whole other universe, floating just a tiny, tiny distance away from ours, in a 4th spatial dimension that we can't perceive? We could be incredibly close to another universe, yet utterly unaware of its presence, separated by a dimension we simply don't have the senses to detect. These are sometimes called brain universes, with our universe being just one thin brain floating in a higher dimensional bulk. These are truly the frontiers of scientific thought, pushing the very limits of what we can imagine and what we can hope to test. We are still in the very early stages of exploring these concepts, but the pursuit itself is incredibly exciting. It's a testament to human curiosity, always striving to understand the biggest picture possible, even if that picture turns out to be far grander and stranger than anything we first conceived. As we continue to float through these mind-expanding ideas, consider the profound shift in perspective a multiverse could bring. For centuries, humanity has pondered the solitary grandeur of our own universe. The thought that this immense, beautiful cosmos might be all there is has been a cornerstone of our understanding. If our universe truly is alone, it holds a unique, almost profound loneliness. It's the one and only stage where all of existence plays out, making every star, every galaxy, every life form incredibly special because there's simply nowhere else for them to be. But if the multiverse is real, that sense of singular uniqueness begins to shift. It doesn't diminish the wonder of our universe, but it embeds it within an even larger, more complex tapestry. It suggests that the cosmic stage isn't singular, but infinitely varied. This changes our fundamental questions. Instead of asking, why this universe? Or, why are its laws just so? The question shifts to, among all possible universes, why do we find ourselves in this particular one? It moves the why question from creation itself to the conditions for our own observation. This journey into the multiverse forces us to question the very nature of reality and our perception of it. If there are infinite versions of you in level 3, living out every possible quantum choice, then which you is the real you? If universes can exist with completely different mathematical rules in level 4, does reality even have a single universal definition? It's like realizing that the simple, solid ground you stand on might actually be just one slice of an impossibly layered, multi-dimensional cake. It pushes us beyond our everyday experiences and intuitions, challenging us to think in ways that feel almost alien to our evolved senses. It's important to remember that, for now, multiverse theories remain in the realm of speculation. They are fascinating, powerful ideas that emerge from our most advanced physics, offering elegant solutions to some of the universe's most perplexing puzzles, like the fine-tuning of its fundamental constants. But they are not yet directly proven. Scientists are working diligently, exploring their implications, looking for those elusive fingerprints we talked about. This is the exciting, cutting-edge of cosmology, where theory dances with the hope of future observation. Yet, despite their speculative nature, the mere existence of these theories sparks our imagination in unparalleled ways. Think of the endless possibilities they present. A universe where gravity repels instead of attracts, where time runs backward, where colors are sounds and sounds are tastes. A universe where every historical event you've ever learned about played out differently, or where you followed a passion you never pursued. The sheer diversity implied by a multiverse is almost too vast for our minds to contain, turning the concept of everything into an ever-expanding, exhilarating mystery. Now, as we continue to journey through these profound concepts, let's once again consider our place within them. If the multiverse is real, and especially if it's the kind of multiverse with widely varying physical laws, then our very existence acts as a kind of cosmic filter. We can only observe, only live within, a universe that allows for our kind of complex chemistry and stable structures. It's not that other universes don't exist, it's that we simply couldn't be in them. Imagine a fish swimming in a small, clear pond. The fish knows its pond intimately, the plants, the rocks, the other fish. But it has no concept of the vast forest surrounding the pond, or the sky above it, or the other ponds scattered across the land. Its entire reality is confined to its watery home. In a similar way, perhaps our universe is just our pond. We are perfectly adapted to its waters, its temperature, its currents. But beyond our cosmic pond, there might be oceans, lakes, and even dry lands, all part of a larger reality that we are simply not equipped to perceive or survive in. Our senses, our biology, our very physical laws are perfectly suited for this universe, and so, this is the universe we observe. This idea, that our observation itself selects a certain kind of universe, is a cornerstone of thinking about the multiverse. It means that even if a multiverse of wildly different realities exists, we will only ever experience the tiny fraction of it that is compatible with our presence. It's a humbling thought, suggesting that our perception of reality is profoundly shaped by our own existence. But even if these theories remain unproven, the very act of contemplating them enriches our understanding of the universe. The beauty of these ideas lies not just in their potential truth, but in their capacity to push the boundaries of human thought. They force us to examine our assumptions about space, time, matter, and existence. They are the ultimate thought experiments, leading us to ask deeper questions and seek more profound answers. The effort to grapple with such colossal concepts, even without definitive proof, expands our intellectual horizons and helps us appreciate the extraordinary ingenuity of the universe itself. And this journey of discovery is far from over. Imagine the advancements in physics and astronomy in the centuries to come. Perhaps new theories will emerge that tie these multiverse concepts together in ways we can't yet fathom. Perhaps subtle clues, currently invisible to our instruments, will finally be detected by future technologies. We are just at the beginning of understanding the full scope of reality. Our current knowledge, as vast as it seems to us, is likely just a tiny island in an ocean of unexplored cosmic truths. It's an exciting time to be alive, to ponder these grand questions, to know that even as we learn more about our own universe, we are simultaneously building theoretical frameworks for what might lie beyond it. The multiverse theories, in their various forms, serve as a constant reminder of the universe's infinite complexity and its unending capacity for surprise. They invite us to embrace the unknown, to look for wonders not just in the observable cosmos, but in the boundless realms of possibility that physics and mathematics suggest. Let's return for a moment to that captivating image of the cosmic foam, the eternally inflating space that might be constantly bubbling off new universes. Imagine this metaspace not as empty void, but as an incredibly vibrant, ever-expanding sea of pure energy. It's a space where the rules of our familiar reality, like the gentle pull of gravity or the constant speed of light, might not even fully apply. Think of it as a primordial, supercharged ocean, where new realities are perpetually being born. In this vast, bubbling expanse, inflation, that incredibly rapid stretching of space, isn't just a one-time event that happened to create our universe. It's an ongoing, chaotic process. Imagine pockets within this energetic foam that, for some reason, slow down their super-fast expansion. When that happens, a tiny region of that inflating space can pinch off, like a miniature balloon separating from a much larger, endlessly growing one. This pinched-off region then becomes a brand new pocket universe, just like ours. And crucially, within that pocket, the leftover energy from its rapid inflation might then transform into all the matter and energy we see in our cosmos, and the expansion settles down to the more gentle rate we observe today. Now, picture this happening not just once, but an infinite number of times. Somewhere, out in this endlessly inflating cosmic ocean, new universes are constantly budding off, like steam rising from a vast, boiling pot. Some might be tiny, others immense. Each one a unique, self-contained reality, distinct from its neighbors, even though they all emerged from the same grand, overarching inflationary process. It's a truly spectacular vision of cosmic creation, one that suggests the universe isn't a singular event, but a never-ending saga of birth. This leads us to a deeper question. If eternal inflation is the engine of the multiverse, what sparked that inflation in the first place? And what are the rules of that overarching, inflating metaspace? Even if we find evidence for bubble universes, we might just be pushing the why question to a higher level. It's like discovering that a single tree has countless branches, but still wondering about the seed that grew the initial tree. The quest for ultimate origins continues, even within the framework of a multiverse. One of the most fascinating aspects of these bubble universes, especially in the Level 2 model, is their profound isolation. Once a bubble universe pinches off, it's largely disconnected from its parent space and from other bubbles. Imagine two distinct bubbles floating in the air. Even if they are very close, the air inside one cannot easily mix with the air inside the other. In the same way, information, light, or matter from another universe cannot typically cross into ours. We are effectively trapped within our own cosmic bubble, unable to peer directly into the countless others. This is why looking for faint bruises in the cosmic microwave background is so important. It's one of the few theoretical ways our universe might have touched another. And within this endless creation, randomness plays a crucial role. When a new pocket universe forms, the values of its fundamental physical constants, the settings on those cosmic dials we talked about, might be determined by random quantum fluctuations in the inflating parent space. Imagine rolling an infinite number of dice, and each die roll determines a fundamental law in a newly formed universe. Some universes might get a bad roll and be completely empty, while others might get a miraculous combination that allows for the emergence of galaxies, stars, and even life. This vast spectrum of possibilities is what makes the existence of our seemingly fine-tuned universe less of a miracle and more of a statistical inevitability within a sufficiently large ensemble of realities. Consider the long-term implications of eternal inflation. If it truly is eternal, never stopping, then the creation of new universes will continue forever. This suggests an endless future of cosmic possibility, where new realities are always being born, experiencing their own big bangs, their own eras of star formation, and their own ultimate fates. It's a universe that is constantly regenerating itself, not just within our own bubble, but across an infinite landscape of creation. Let's also revisit the implications of the Level 3, many worlds multiverse, where every quantum possibility leads to a branching reality. This isn't just about your big life choices. Imagine the tiniest particles inside your body. Every single time an electron absorbs or emits a photon, every time an atom decays, every time a quantum wave function collapses into a definite state, the universe might be splitting. The sheer scale of this branching is almost beyond human comprehension. It means that in parallel realities, every single possible quantum outcome of every single interaction is actualized. Think about the light from a distant star hitting your eye. A photon travels across light years. When it hits the cells in your retina, that's a quantum event. In one universe, that photon hits a specific receptor. In another, it hits a slightly different one, or perhaps it didn't hit your eye at all and continued on its way. Each of these possibilities gives rise to a new, branching universe. This means that at every moment, the number of parallel universes multiplies exponentially, leading to an incredibly dense forest of realities, all slightly or vastly different, yet all existing simultaneously in some abstract sense. It makes you wonder, doesn't it, if there are infinite versions of you living out every conceivable permutation of your life, does it truly diminish your own unique journey in this specific reality? Or does it simply expand the definition of you to encompass an infinite spectrum of experiences across an unimaginably vast tapestry of existence? It's a question that resonates deeply within us, challenging our very sense of self and the boundaries of our individual consciousness. The multiverse, in its various forms, pushes us to contemplate these profound questions, forever expanding our understanding of what is real. As we dive deeper into these cosmic what-ifs, the implications become even more astonishing. Imagine a universe where the strong nuclear force, the glue that holds atomic nuclei together, is slightly weaker. In such a universe, atoms heavier than hydrogen might never form, meaning no carbon, no oxygen, no nitrogen. It would be a cosmos of only the simplest elements, a dilute, gaseous expanse, incapable of forming solid planets or complex chemistry. Life, as we know it, would be impossible. Or consider a universe where the electromagnetic force is far stronger. Then electrons would be so tightly bound to atomic nuclei that chemical reactions, the very dance of atoms that creates molecules and living organisms, could never occur. These aren't just subtle differences, they are fundamental shifts that would create realities utterly unrecognizable to us, barren of stars, planets, and certainly any form of conscious observers. The sheer variety across these hypothetical universes is breathtaking. Some might be dominated by exotic forms of matter that we can only dream of. Others might have entirely different numbers of spatial dimensions. Perhaps there are universes where beings navigate through 5 or 7 dimensions, perceiving reality in ways that would shatter our minds. Imagine communication in a 4-dimensional universe, where you could literally step around an obstacle without going through or over it. The very concept of up or down might be entirely different. These aren't just thought experiments for fun. They are often direct consequences derived from the complex equations of cutting-edge physics, equations that hint at possibilities far beyond our everyday experience. This brings us back to the level 4 mathematical universe hypothesis. If physical reality is a mathematical structure, then information takes on a fundamentally new role. In this view, reality isn't just described by information, it is information. Every property, every interaction, every particle is an informational entity, part of a larger mathematical pattern. This would mean that the universe exists not because it was created in a traditional sense, but because its mathematical description is self-consistent and coherent. It's like a perfectly constructed symphony that exists because its notes and harmonies are mathematically sound, whether anyone is there to hear it or not. The existence isn't contingent on an observer, but on its inherent logical structure. The beauty of multiverse theories, despite their current speculative nature, is how they serve as powerful testing grounds for our deepest theories. Inflationary cosmology, for example, is our leading theory for explaining the uniformity and flatness of our universe. But if inflation is true, the mathematical models that describe it almost inevitably lead to the concept of eternal inflation and the birth of bubble universes. Similarly, string theory, one of our best hopes for a theory of everything that unifies all the fundamental forces, often suggests the existence of extra dimensions and a vast landscape of possible universes, each with different physical laws. So, the multiverse isn't just a standalone idea, it's often a profound consequence of our most successful and ambitious scientific frameworks. If these underlying theories are correct, then some form of multiverse might be an unavoidable conclusion. And what about time in this grand multiverse? In our universe, time seems to flow relentlessly forward, from past to future, often linked to the increase of disorder or entropy. But in the larger metaspace of an eternally inflating multiverse, or across branching quantum realities, the concept of a single, universal cosmic time becomes incredibly complex. Some theories suggest that time itself might behave differently in different bubble universes, or that the parent, inflationary space, might not even have a conventional arrow of time at all. Each universe could have its own beginning, its own lifespan, its own unique temporal progression, existing simultaneously but in utterly disparate temporal flows within the larger, timeless or multi-temporal framework of the multiverse. It's like countless rivers, each with its own current, flowing through a vast, boundless ocean. The aesthetic and intellectual appeal of these theories is undeniable. They satisfy a deep human yearning to understand not just our place, but the very nature of existence itself. They paint a picture of reality that is far richer, far more diverse, and far more awe-inspiring than a single, isolated cosmos could ever be. They offer a sense of boundless possibility, a constant invitation to imagine beyond the familiar. Even if definitive proof remains out of reach for centuries, the theoretical exploration of the multiverse expands our minds, pushing the frontiers of human thought and creativity. The challenge, of course, lies in the limits of observation and experimentation. How do you measure something that, by definition, is outside your observable horizon, or something that exists in a parallel reality that doesn't interact with ours? It's a bit like trying to study an entire library by only ever being allowed to read one specific book. We're confined to our book, our universe, and can only infer the existence of the rest of the library through subtle clues or the logical consistency of our theories. This is why the search for those fingerprints, like the cold spot in the cosmic microwave background or faint gravitational wave echoes, is so crucial. They are our tenuous threads, our only potential lifelines to confirming something beyond our immediate cosmic grasp. But even without direct empirical confirmation, the multiverse stands as a powerful testament to the ever-evolving nature of scientific understanding. It reminds us of the profound humility required in the pursuit of knowledge. The universe, in all its majestic complexity, continues to hold secrets far grander and stranger than we can currently imagine. And perhaps, the greatest wonder of all is not just what is, but what else could be. But even without direct empirical confirmation, the multiverse stands as a powerful testament to the ever-evolving nature of scientific understanding. It reminds us of the profound humility required in the pursuit of knowledge. The universe, in all its majestic complexity, continues to hold secrets far grander and stranger than we can currently imagine. And perhaps, the greatest wonder of all is not just what is, but what else could be. Imagine a realm where every logically consistent idea, every complete mathematical puzzle, automatically becomes a living, breathing reality. This is the ultimate extension of the Level 4 multiverse concept, pushing the boundaries of what we consider existence beyond anything we can touch or see. In this view, reality isn't something that needs to be created by a big bang. It simply is, in all its possible mathematically consistent forms. It's like a vast, cosmic democracy of ideas, where any valid concept automatically gains the status of a universe. This perspective profoundly shifts our view of our own universe. Instead of being a uniquely special creation, it becomes just one particularly interesting solution to a set of mathematical equations. It's the one that happens to allow for complex structures, stars, planets, and crucially, beings capable of contemplating its existence. This idea of the anthropic landscape comes into even sharper focus here. Think of it as a vast terrain of possibilities, where each peak and valley represents a different set of physical laws. Most of these landscapes are barren, impossible to traverse for anything resembling life. But here and there, a small, hospitable valley emerges, where the conditions are just right. Our universe, then, is one of those fortunate valleys. This is a form of cosmic natural selection, not in the biological sense of fittest individuals surviving, but in the sense that only those universes with the right properties can give rise to observers. The fine-tuning we discussed earlier, those incredibly precise settings on the cosmic dials, suddenly becomes less of a mystery and more of an inevitability. If you have an infinite number of universes, with infinite variations in their dials, then somewhere, the winning lottery ticket for life will be drawn. We are simply living on that winning ticket. It's a powerful argument for the multiverse, because it neatly explains why our universe, appears so perfectly designed for us, without requiring any supernatural intervention. Let's also revisit the intensely personal implications of the Level 3 Many Worlds multiverse. If every quantum choice, every tiny probabilistic event, causes the universe to branch, then the sheer number of parallel yous becomes truly unfathomable. Imagine moments in your life, deciding what to eat for dinner, choosing a path to walk, even the random flicker of a light in your peripheral vision. Each moment, in this theory, spawns new versions of reality. This means that every single alternative choice you didn't make is being lived out by a copy of you in a different, equally real universe. It leads to fascinating and perhaps unsettling questions about identity and free will. If all possible outcomes are realized in some universe, does your choice truly matter? Are you truly free, or are you simply riding one specific wave in an ocean of already actualized possibilities? It's a deep, philosophical rabbit hole. However, proponents of many worlds would argue that you are the experience of your particular branch. Your consciousness, your memories, your choices define your path through this branching tree of realities. So, in a sense, your choices still matter deeply to your experience, even if other versions of you are making different choices elsewhere. It becomes less about a single destiny and more about an endless spectrum of potential selves. And where does consciousness fit into such a grand tapestry? In a multiverse where realities are constantly splitting, or where infinite variations exist, perhaps consciousness itself isn't confined to a single, isolated brain in a single universe. Some highly speculative ideas even touch upon the concept of a multiverse of minds, where consciousness might be a more fundamental property of reality, capable of existing in various forms across different universes. This is truly venturing into the realm of profound unknowns, but it shows how far these ideas can push our thinking about life, mind, and reality itself. Despite the tantalizing nature of these theories, the scientific community approaches them with a healthy dose of skepticism and rigor. The extraordinary claims of a multiverse require extraordinary evidence. While the mathematical consistency and explanatory power of these theories are compelling, they remain hypotheses until observable evidence can be found. This constant tension between brilliant theoretical ideas and the stringent demands of empirical proof is what drives scientific progress forward. It's a reminder that even the most beautiful or compelling idea must eventually face the crucible of observation. The ongoing search for those elusive fingerprints in the cosmic microwave background, or the faint gravitational echoes from distant, unimaginable events, continues. Every new generation of telescopes and detectors brings us closer to probing the very edge of our observable universe, and perhaps, just perhaps, detecting a subtle whisper from beyond. The universe, in its boundless mystery, continues to invite us to ponder the truly grand questions that might lead us not just to a deeper understanding of our own cosmos, but to the breathtaking realization of a reality far more vast and diverse than we ever dared to dream. Now, let's take another imaginative leap, one that some consider to be yet another form of the multiverse, though it approaches the concept from a very different angle. This is the intriguing, and sometimes unsettling, idea that our entire universe, with all its stars, galaxies, and living beings, might actually be a simulation within a much higher level reality. Imagine a super advanced civilization, perhaps billions of years more evolved than us, with computing power so immense that they could create an entire universe, complete with fundamental laws of physics, evolving galaxies, and even conscious beings. Our universe, then, would be like an incredibly complex, detailed video game running on their colossal supercomputer. This isn't strictly a multiverse in the sense of separate physical universes, but it suggests a hierarchical reality where our universe is nested within another, which might itself be nested within another, and so on. It's a bit like Russian nesting dolls, but with entire realities inside. The implications of such a simulated universe are profound. What would it mean for our reality if everything we perceive, every thought we have, every emotion we feel, is essentially a line of code in some super program? Would our choices still be real? Would our universe have a programmer? It's a concept that blurs the lines between reality and illusion, science and philosophy, in truly fascinating ways. Some scientists have even playfully suggested ways we might detect such a simulation, Could there be tiny glitches in the fabric of reality, like pixels on a screen that occasionally misbehave? Could fundamental constants or physical laws have rounding errors that hint at a finite computational grid? Or might there be a subtle speed limit on information, like a processing bottleneck, that we could detect? These are highly speculative thoughts, often more science fiction than current science, but they highlight how the multiverse idea, in its broadest sense, can extend into deeply philosophical territory. It asks us to consider that reality itself might be far more malleable and constructed than we typically assume. This idea of infinite possibilities isn't new. Philosophers throughout history have pondered something called the principle of plenitude, which suggests that if something is possible, then it must, in some form, actually exist. This ancient idea finds a modern echo in multiverse theories. If the laws of physics allow for a certain kind of universe to exist, with specific properties, then in a truly grand multiverse, that universe isn't just a theoretical possibility. It's a realized reality somewhere out there, or in some parallel branch. It transforms the concept of potentiality into actuality on a cosmic scale. Let's return to the idea of those varying fundamental constants in Level 2 universes. Imagine how this impacts the very earliest moments of these universes. In some, the initial expansion might have been so rapid that hydrogen and helium atoms never had a chance to form, leaving a universe that is just pure, undifferentiated energy. In others, the early universe might have been so dense that it immediately collapsed back in on itself, experiencing a big crunch before anything truly interesting could happen. Our universe, with its gentle expansion, its perfect formation of light elements, and its subsequent long, stable period for star and galaxy formation, is incredibly lucky, a cosmic Goldilocks zone. And what about the ultimate fates of these different universes? While our universe is currently accelerating towards a potential big freeze or big rip, where everything eventually gets torn apart or fades into cold emptiness, other universes in the multiverse might face entirely different destinies. Some might end in a big crunch, collapsing back into a single point, perhaps to rebound into another big bang. Others might oscillate, constantly expanding and contracting. The grand tapestry of the multiverse, therefore, would include an infinite variety of cosmic life cycles, each playing out its own unique drama of creation, evolution, and ultimate demise within the larger, eternal framework. These multiverse theories are not static, they are constantly evolving. As our understanding of quantum mechanics deepens, as new insights into gravity and space-time emerge, and as our ability to analyze cosmic data improves, these ideas will undoubtedly be refined, challenged, and perhaps even transformed. What seems like wild speculation today might, in centuries to come, become a cornerstone of cosmic understanding. It's a living, breathing field of inquiry, always pushing the limits of our knowledge, inviting us to be part of the most ambitious intellectual adventure humanity has ever undertaken, understanding the true nature of all that is and all that could be. Now, as we ponder the endless realms of possibility that a multiverse suggests, a very deep and ancient question arises. Does it actually solve the ultimate mystery of cosmic origins, the first cause problem? For centuries, philosophers and scientists have grappled with why there is something rather than nothing. If our universe sprang from a Big Bang, what caused the Big Bang? If the multiverse is an eternally inflating, bubbling foam, then what caused that foam to exist in the first place? It seems that while the multiverse pushes the origin story far, far back, perhaps even infinitely back, it might not provide a definitive beginning in the traditional sense. Instead, the multiverse could suggest that existence is fundamental, that the laws of the overarching meta, space, are simply what is, without a need for a prior cause. It's like asking what causes the rules of arithmetic to exist. They just are. In this view, the multiverse might not have a beginning or an end in the way we understand it. It simply exists, an eternal, boundless source of creation, an endless machine churning out realities. This shifts the focus from finding a single starting point to understanding the enduring, ever-present nature of being itself. This also brings us to the fascinating challenge of developing a metaphysics for the multiverse. If there are multiple universes, what are the overarching principles that govern them all? Are there laws that apply across all universes, regardless of their individual physical constants or dimensions? Or is each universe truly a law unto itself, emerging from pure randomness within the larger cosmic foam? This is a frontier of theoretical physics, attempting to understand the rules of the game at a level even deeper than the laws of our own universe. Imagine trying to deduce the rules of chess by only ever seeing a single game being played. It's a monumental intellectual task, requiring revolutionary new insights. If the multiverse turns out to be real, it profoundly impacts the very nature of the scientific method. Traditionally, science relies on observation and experimentation within our single universe. But how do you test theories about something you can't observe? This is where the concept of probability and statistics becomes even more critical. If the multiverse is a statistical ensemble of possibilities, then we can only make probabilistic predictions about what kinds of universes are likely to exist, and what kinds of universes are likely to host observers like us. It shifts from deterministic predictions to statistical likelihoods, a different but equally valid way of doing science in the face of such immense complexity. Consider the implications for the sheer quantity of matter and energy in the multiverse. If new universes are constantly bubbling off, each potentially containing vast amounts of energy and matter, then the total amount of stuff in the multiverse could be truly infinite, or at least beyond any number we can grasp. This doesn't mean that matter is constantly popping into existence in our local neighborhood, but rather that the overall cosmic reservoir of being is immense and continually expanding through the creation of new pocket realities. It changes our perspective from a single, finite cosmic budget to an unimaginably rich, infinite cosmic economy. For us, as conscious beings living our lives, the philosophical and existential impact of a multiverse is immense. Does it make our individual lives less special, knowing that there might be infinite copies of us, living out every possible permutation of our existence? Or does it make our particular journey, in this specific universe, with these specific choices and experiences, even more precious? It might seem to diminish our significance at first glance, but it can also be seen as an immense expansion of what existence means. Your life here, now, is a unique and incredibly fortunate realization within an unbounded realm of cosmic potential. It transforms our sense of purpose from a singular, predetermined path to one filled with boundless possibilities, reminding us that every moment, every choice, is a unique unfolding within the grand cosmic narrative. The human mind, in its extraordinary capacity, is constantly striving to comprehend the incomprehensible. Multiverse theories, more than almost any other scientific concept, push the limits of our imagination. They force us to transcend our everyday experience of reality and conceive of dimensions, laws, and possibilities that seem to belong solely in the realm of dreams or pure fantasy. Yet, they arise from the rigorous, logical frameworks of mathematics and physics. This blend of abstract logic and wild imagination is what makes the journey into the multiverse so captivating. It's a dance between the known and the utterly unknown, a constant invitation to stretch our minds and embrace the grandest mysteries the cosmos has to offer. The human mind, in its extraordinary capacity, is constantly striving to comprehend the incomprehensible. Multiverse theories, more than almost any other scientific concept, push the limits of our imagination. They force us to transcend our everyday experience of reality and conceive of dimensions, laws, and possibilities that seem to belong solely in the realm of dreams or pure fantasy. Yet, they arise from the rigorous, logical frameworks of mathematics and physics. This blend of abstract logic and wild imagination is what makes the journey into the multiverse so captivating. It's a dance between the known and the utterly unknown, a constant invitation to stretch our minds and embrace the grandest mysteries the cosmos has to offer. Now, let's take another imaginative leap, one that some consider to be yet another form of the multiverse, though it approaches the concept from a very different angle. This is the intriguing and sometimes unsettling idea that our entire universe, with all its stars, galaxies, and living beings, might actually be a simulation within a much higher level reality. Imagine a super advanced civilization, perhaps billions of years more evolved than us, with computing power so immense that they could create an entire universe, complete with fundamental laws of physics, evolving galaxies, and even conscious beings. Our universe, then, would be like an incredibly complex, detailed video game running on their colossal supercomputer. This isn't strictly a multiverse in the sense of separate physical universes, but it suggests a hierarchical reality where our universe is nested within another, which might itself be nested within another, and so on. It's a bit like Russian nesting dolls, but with entire realities inside. The implications of such a simulated universe are profound. What would it mean for our reality if everything we perceive, every thought we have, every emotion we feel, is essentially a line of code in some super program? Would our choices still be real? Would our universe have a programmer? It's a concept that blurs the lines between reality and illusion, science and philosophy, in truly fascinating ways. Some scientists have even playfully suggested ways we might detect such a simulation. Could there be tiny glitches in the fabric of reality, like pixels on a screen that occasionally misbehave? Could fundamental constants or physical laws have rounding errors that hint at a finite computational grid? Or might there be a subtle speed limit on information, like a processing bottleneck, that we could detect? These are highly speculative thoughts, often more science fiction than current science, but they highlight how the multiverse idea, in its broadest sense, can extend into deeply philosophical territory. It asks us to consider that reality itself might be far more malleable and constructed than we typically assume. This idea of infinite possibilities isn't new. Philosophers throughout history have pondered something called the principle of plenitude, which suggests that if something is possible, then it must, in some form, actually exist. This ancient idea finds a modern echo in multiverse theories. If the laws of physics allow for a certain kind of universe to exist, with specific properties, then in a truly grand multiverse, that universe isn't just a theoretical possibility. It's a realized reality somewhere out there, or in some parallel branch. It transforms the concept of potentiality into actuality on a cosmic scale. Let's return to the idea of those varying fundamental constants in Level 2 universes. Imagine how this impacts the very earliest moments of these universes. In some, the initial expansion might have been so rapid that hydrogen and helium atoms never had a chance to form, leaving a universe that is just pure, undifferentiated energy. In others, the early universe might have been so dense that it immediately collapsed back in on itself, experiencing a big crunch before anything truly interesting could happen. Our universe, with its gentle expansion, its perfect formation of light elements, and its subsequent long, stable period for star and galaxy formation, is incredibly lucky, a cosmic Goldilocks zone. And what about the ultimate fates of these different universes? While our universe is currently accelerating towards a potential big freeze or big rip, where everything eventually gets torn apart or fades into cold emptiness, other universes in the multiverse might face entirely different destinies. Some might end in a big crunch, collapsing back into a single point, perhaps to rebound into another big bang. Others might oscillate, constantly expanding and contracting. The grand tapestry of the multiverse, therefore, would include an infinite variety of cosmic life cycles, each playing out its own unique drama of creation, evolution, and ultimate demise within the larger, eternal framework. These multiverse theories are not static, they are constantly evolving. As our understanding of quantum mechanics deepens, as new insights into gravity and space-time emerge, and as our ability to analyze cosmic data improves, these ideas will undoubtedly be refined, challenged, and perhaps even transformed. What seems like wild speculation today might, in centuries to come, become a cornerstone of cosmic understanding. It's a living, breathing field of inquiry, always pushing the limits of our knowledge, inviting us to be part of the most ambitious intellectual adventure humanity has ever undertaken, understanding the true nature of all that is and all that could be. Now, let's peer deeper into the very fabric of space itself. One of the most perplexing mysteries in our own universe is the nature of the cosmic vacuum, often referred to as empty space. According to quantum mechanics, empty space is far from empty. It's a frothing sea of virtual particles constantly popping in and out of existence. This activity should contribute a tremendous amount of energy to the vacuum, known as vacuum energy, or the cosmological constant. The problem is, our calculations suggest this energy should be incredibly, impossibly vast. causing the universe to expand at an unimaginable rate. Yet observations show that the vacuum energy is tiny, almost zero, just enough to gently accelerate the cosmic expansion. This colossal discrepancy is one of the biggest puzzles in modern physics. The multiverse, particularly the Level 2 bubble universe model, offers a compelling solution. Imagine that in the vast, eternally inflating metaspace, the vacuum energy can take on a myriad of different values. Each time a new bubble universe forms, it randomly samples a different value for its vacuum energy. Most of these universes would have the huge, destructive vacuum energy predicted by theory, expanding so fast that no stars or galaxies could ever form. They would be cold, empty, and utterly devoid of anything complex. But if there are an infinite number of such universes, then somewhere, by pure chance, a universe would arise with an extraordinarily tiny, life-permitting vacuum energy, just like ours. We exist in this particular universe precisely because it's one of the rare ones where life can actually take root and thrive. It's the ultimate cosmic lottery, and we won the grand prize. Consider also the intriguing Big Bounce theory, an alternative to the standard Big Bang. Instead of our universe beginning from an infinitely dense singularity, the Big Bounce proposes that our Big Bang was actually the result of a previous universe contracting, reaching a minimum size, and then bouncing back out into expansion. It suggests a cyclical universe, an endless loop of expansion and contraction. If the Big Bounce is true, it doesn't just mean a previous universe. It could imply an infinite chain of universes, each emerging from the collapse of its predecessor. This turns the entire multiverse into a vast, pulsating cosmic engine, constantly recycling and regenerating reality, with no absolute beginning or end to the cycle. It connects the fate of one universe directly to the birth of the next, weaving them into an even grander, interconnected dance. And then there's the truly mind-bending holographic principle. Imagine that all the information contained within our three-dimensional universe, everything we see and experience, is actually encoded on a distant, two-dimensional boundary, much like a hologram projects a 3D image from a 2D surface. This doesn't mean our reality isn't real, but that it's a projection, a deeper, more fundamental reality existing on a lower dimensional surface. If this principle holds true for our universe, it raises the possibility that the entire multiverse could similarly be a projection from an even higher dimensional, more fundamental reality, hinting at layers of existence far beyond our current comprehension. It's a bit like discovering that the universe isn't a solid object, but a luminous, cosmic illusion, a grand projection from a hidden, deeper source. Our observable universe, the sphere of space from which light has had time to reach us since the Big Bang, is only a fraction of what likely exists. Beyond this cosmic horizon, there's a vast expanse of space, and perhaps other universes that we simply cannot see, because their light hasn't reached us yet, or may never reach us due to the accelerating expansion of space. This horizon acts as a kind of perceptual boundary, a veil beyond which our direct instruments cannot peer. But the multiverse theories suggest that this boundary is not the end of reality, but merely the limit of our current vision. And in the complex world of string theory, the concept of the landscape of universes emerges. String theory posits that the universe's fundamental particles aren't point-like, but tiny, vibrating strings. For this theory to work in our 3D space, it requires extra spatial dimensions, usually 6 or 7, to be curled up or compactified into tiny, unseen shapes. The number of ways these extra dimensions can be curled up is astronomically vast, perhaps 10 to the power of 500 different ways. Each unique way of compactifying these dimensions results in a different set of physical laws and constants for a universe. Our universe, with its specific laws, corresponds to just one particular shape in this immense landscape. It's a bit like choosing one specific path through a fantastically complex, multidimensional maze, and that path dictates all the rules of your reality. The sheer scale of these multiverse ideas, from the simulated reality to the Big Bounce, from vacuum energy variations to string theory landscapes, can evoke a powerful mix of emotions. There's a profound awe at the universe's boundless creativity, a sense of humility at the limitations of our current understanding, and perhaps even a touch of anxiety at the thought of infinite versions of ourselves or realities where nothing makes sense. But ultimately, for many, It's an exhilarating invitation to embrace the unknown, to continue to ask the biggest questions, and to push the very limits of what it means to exist. The sheer scale of these multiverse ideas, from the simulated reality to the Big Bounce, from vacuum energy variations to string theory landscapes, can evoke a powerful mix of emotions. There's a profound awe at the universe's boundless creativity, a sense of humility at the limitations of our current understanding, and perhaps even a touch of anxiety at the thought of infinite versions of ourselves or realities where nothing makes sense. But ultimately, for many, it's an exhilarating invitation to embrace the unknown, to continue to ask the biggest questions, and to push the very limits of what it means to exist. Now, as we continue our silent drift through the cosmic wonders, a very important question often comes up when discussing multiverse theories. Are they truly science? Or are they just fascinating philosophical ideas? This is where the concept of falsifiability comes into play. In science, a theory is generally considered scientific, if there's a way, at least in principle, to prove it wrong. If you can't imagine any observation or experiment that would contradict a theory, then it's hard to test, and therefore, some argue, it's not truly scientific. For many multiverse theories, direct observation is incredibly difficult, perhaps impossible. How do you travel to another universe to check if it's there? How do you know if a quantum branch actually happened? This has led to lively debates in the scientific community. Critics sometimes suggest that if a theory can explain anything by simply saying, "It happened in another universe," then it effectively explains nothing in our universe. However, proponents of multiverse theories argue that this view is too narrow. They contend that even if direct observation is impossible, these theories do make predictions about our own universe, predictions that can be tested. For example, if the level 2 bubble universes exist and sometimes collide, we might expect to find those telltale bruises or anomalies in the cosmic microwave background, like the strange cold spot we discussed. Or, if certain versions of string theory are true and imply a particular kind of multiverse, there might be subtle, indirect signals in future particle accelerator experiments that hint at the existence of extra dimensions or exotic particles. These aren't direct observations of another universe, but they are observable consequences within our own universe that would lend strong support to a multiverse hypothesis. Imagine being a detective trying to solve a puzzle. You can't see the entire crime scene, but you can gather clues within your limited view. A single, consistent explanation that accounts for all the strange clues, even those that seem unrelated, can be a powerful argument, even if you never directly witness the whole scenario. Multiverse proponents view these theories in a similar light. They offer elegant solutions to stubborn puzzles in our own universe, like the fine-tuning problems of dark energy and fundamental constants. The consistency and explanatory power, combined with potential indirect observational fingerprints, are what keep these ideas firmly rooted in scientific inquiry, rather than pure fantasy. The future of observational cosmology is incredibly exciting in this context. Next-generation space telescopes, far more powerful than anything we have today, might be able to map the cosmic microwave background with even greater precision, perhaps revealing more subtle anomalies. Future gravitational wave detectors, even more sensitive than our current ones, might someday detect those incredibly faint ripples from the very early universe, potentially even from the moments when universes might have collided or budded off. We are always refining our tools, pushing the boundaries of what's detectable. It's a race against time and technology, as we strive to build instruments capable of listening for the faintest whispers from the earliest moments of cosmic history. Let's briefly return to the Level 3 Many Worlds interpretation and its attempt to solve one of the deepest puzzles in quantum mechanics, the measurement problem. Remember how tiny particles can exist in multiple states at once, like a spinning coin that's both heads and tails? Quantum theory says that only when you observe or measure the particle does it choose a single state, like the coin landing. But why does that happen? What causes the wave of possibilities to collapse into one definite reality? The many worlds interpretation sidesteps this problem entirely. It says the wave of possibilities never collapses. Instead, every time a measurement is made, or any quantum interaction occurs, the universe simply splits into multiple branches, each representing a different possible outcome. So, the coin doesn't land on heads or tails. It lands on heads in one universe and on tails in a parallel universe. This means there's no mysterious collapse of possibilities. All possibilities are actualized, just in different, separate realities. It's an elegant, if mind-bending, solution that removes a major conceptual headache from quantum physics at the cost of multiplying universes. And this idea of all possibilities being actualized can even touch upon the ultimate fate of information, particularly when we consider black holes. When something falls into a black hole, does the information about it disappear forever? According to quantum mechanics, information can never truly be destroyed. This leads to the black hole information paradox. If information can't be destroyed, where does it go inside a black hole? Some highly speculative ideas, sometimes loosely linked to multiverse concepts, propose that perhaps the information doesn't disappear, but instead branches into another universe or dimension, effectively leaving our reality. It's a way of saying that the universe has an escape hatch for information, always preserving it, even if it's no longer within our grasp. The allure of mathematical consistency is also a powerful driver for these theories. For physicists, if a theory is beautiful, elegant, and mathematically sound, it often hints at a deeper truth about nature. The various multiverse scenarios, while diverse, often emerge as consistent mathematical consequences of our most fundamental theories about the universe. This inherent logical beauty, combined with their explanatory power for phenomena like fine-tuning, makes them incredibly compelling, even in the absence of direct proof. It's a faith, in a way, that the universe operates on principles of elegant simplicity, even if those principles lead to unimaginably complex consequences. Ultimately, the human need for understanding is perhaps the most fundamental reason we continue to explore these concepts. We are driven by an innate curiosity to comprehend our place in the cosmos, to understand not just how our universe works, but why it is the way it is. Multiverse theories, in their grand scope, attempt to address some of the deepest why questions, questions that have puzzled humanity for millennia. They are a testament to our boundless intellectual ambition, our tireless quest to map the outermost reaches of reality, even if those reaches extend far beyond the limits of our immediate perception. Ultimately, the human need for understanding is perhaps the most fundamental reason we continue to explore these concepts. We are driven by an innate curiosity to comprehend our place in the cosmos, to understand not just how our universe works, but why it is the way it is. Multiverse theories, in their grand scope, attempt to address some of the deepest why questions, questions that have puzzled humanity for millennia. They are a testament to our boundless intellectual ambition, our tireless quest to map the outermost reaches of reality, even if those reaches extend far beyond the limits of our immediate perception. Now, as we continue our thoughtful drift through these profound cosmic ideas, let's circle back to that idea of our universe being just right for life, a concept sometimes called the anthropic principle. This principle comes in a couple of flavors, and understanding them helps clarify the role of the multiverse. The weak anthropic principle is fairly straightforward. It simply says that the universe's properties must be compatible with the existence of intelligent life at some point in its history, because otherwise, there wouldn't be anyone around to observe it. It's an observation, not an explanation. It doesn't say why the universe is the way it is, only that since we're here, it must have been that way. The multiverse provides a powerful explanation for this. If there are countless universes with varying properties, then it's no surprise that we find ourselves in one that can support us. We are simply in the habitable zone of the cosmic landscape. The strong anthropic principle, on the other hand, is a much bolder claim. It suggests that the universe must have those life-permitting properties, as if there was some underlying purpose or design. This is where the multiverse often steps in to offer a natural, non-purposeful explanation, arguing that a vast ensemble of universes makes our existence statistically probable rather than miraculously unique. It essentially moves the apparent design from a single universe to the grand, random process of the multiverse itself. Let's venture again into the truly speculative implications of the Level 3 Many-Worlds multiverse. This is where the concept of quantum immortality sometimes arises, though it's more of a philosophical thought experiment than a scientific prediction. If every quantum event causes the universe to branch, and consciousness is tied to these quantum states, then theoretically, every time you face a life or death situation, or even just a random quantum fluctuation that could lead to your demise, your consciousness would simply follow the branch where you survive. Imagine you're playing a cosmic game of Russian roulette, but in a many-worlds multiverse. Every time the trigger is pulled, in one universe, the bullet fires, and you're gone. But in another parallel universe, the gun doesn't fire, and you continue to exist. From your perspective, you would always experience survival, constantly jumping to the branch where you live. This is, of course, a deeply unsettling and highly speculative idea, relying on a very specific interpretation of consciousness and quantum mechanics. It's a vivid example of how far our minds can stretch when trying to grapple with the implications of an endlessly branching reality. It challenges the very finality of death in a way that feels both liberating and terrifying. Now, a humorous but also very serious challenge to the idea of an infinitely vast universe, like in Level 1, is known as the Boltzmann brain problem. If you have an infinite universe, and given enough time, any possible arrangement of atoms will eventually spontaneously appear, then it becomes statistically more likely for a random collection of atoms to spontaneously form a disembodied brain that only thinks it's experiencing a universe, rather than for an entire universe to evolve into complex life forms. Imagine the sheer randomness of a boiling soup of particles. Every now and then, a collection of those particles might, by pure chance, briefly arrange themselves into a functioning brain that has memories and perceptions, even if it exists for only a fleeting moment before dissolving. The Boltzmann brain argument suggests that in an infinite, truly random universe, there would be vastly more of these randomly formed, disembodied brains than actual, complex, evolved observers like us. This would be a problem for the infinite universe idea, because if it were true, we would be far more likely to be a Boltzmann brain than a real person living in a real universe. This puzzle highlights the need for the multiverse theories to also explain why stable, complex, and evolving universes like ours are the dominant form, rather than just random, fleeting fluctuations. The very structure of our universe is built upon symmetries, properties that remain unchanged even when something is transformed. Think of a snowflake. It has a six-fold symmetry. In physics, fundamental laws often have symmetries, but sometimes these symmetries are broken as the universe cools or evolves. Imagine a perfect, symmetrical glass of water. As it freezes, the ice crystals that form break that perfect symmetry, creating a specific, structured pattern. In some multiverse theories, the different physical laws of different universes might arise from different ways that these fundamental symmetries were broken in their respective cosmic cooling processes. Each unique way a symmetry breaks could define a distinct set of cosmic rules for a new universe, contributing to the Level 2 diversity. Our universe is also governed by a strict cosmic speed limit, the speed of light. Nothing can travel faster than light through space. This fundamental speed limit plays a crucial role in maintaining the isolation of different universes, or even distant regions within an infinite universe. Even if there are other bubble universes incredibly close to ours in some higher dimension, the speed of light ensures that information from them cannot bleed into ours, reinforcing their separate existence. It's a cosmic barrier, ensuring that our reality remains distinct, even if surrounded by an ocean of others. Beyond the scientific utility and explanatory power of these theories, there is an immense aesthetic value to the idea of a multiverse. It paints a picture of existence that is far grander, far more creative, and far more diverse than any single universe could ever be. It's a cosmic masterpiece with an infinite number of canvases, each displaying a unique and astonishing design. It elevates the universe from a single narrative to an epic, multi-volume saga, an endlessly unfolding story of cosmic potential. It invites us to appreciate not just the universe we inhabit, but the boundless, unimaginable tapestry of all that is and all that could ever be. Beyond the scientific utility and explanatory power of these theories, there is an immense aesthetic value to the idea of a multiverse. It paints a picture of existence that is far grander, far more creative, and far more diverse than any single universe could ever be. It's a cosmic masterpiece with an infinite number of canvases, each displaying a unique and astonishing design. It elevates the universe from a single narrative to an epic, multi-volume saga, an endlessly unfolding story of cosmic potential. It invites us to appreciate not just the universe we inhabit, but the boundless, unimaginable tapestry of all that is and all that could ever be. Now, as we continue our thoughtful drift through these profound cosmic ideas, let's circle back to that idea of our universe being just right for life. A concept sometimes called the anthropic principle. This principle comes in a couple of flavors, and understanding them helps clarify the role of the multiverse. The weak anthropic principle is fairly straightforward. It simply says that the universe's properties must be compatible with the existence of intelligent life at some point in its history, because otherwise, there wouldn't be anyone around to observe it. It's an observation, not an explanation. It doesn't say why the universe is the way it is, only that since we're here, it must have been that way. The multiverse provides a powerful explanation for this. If there are countless universes with varying properties, then it's no surprise that we find ourselves in one that can support us. We are simply in the habitable zone of the cosmic landscape. The strong anthropic principle, on the other hand, is a much bolder claim. It suggests that the universe must have those life-permitting properties, as if there was some underlying purpose or design. This is where the multiverse often steps in to offer a natural, non-purposeful explanation, arguing that a vast ensemble of universes makes our existence statistically probable rather than miraculously unique. It essentially moves the apparent design from a single universe to the grand, random process of the multiverse itself. Let's venture again into the truly speculative implications of the Level 3 Many Worlds multiverse. This is where the concept of quantum immortality sometimes arises, though it's more of a philosophical thought experiment than a scientific prediction. If every quantum event causes the universe to branch, and consciousness is tied to these quantum states, then theoretically, every time you face a life or death situation, or even just a random quantum fluctuation that could lead to your demise, your consciousness would simply follow the branch where you survive. Imagine you're playing a cosmic game of Russian roulette, but in a many worlds multiverse. Every time the trigger is pulled, in one universe, the bullet fires, and you're gone. But in another parallel universe, the gun doesn't fire, and you continue to exist. From your perspective, you would always experience survival, constantly jumping to the branch where you live. This is, of course, a deeply unsettling and highly speculative idea, relying on a very specific interpretation of consciousness and quantum mechanics. It's a vivid example of how far our minds can stretch when trying to grapple with the implications of an endlessly branching reality. It challenges the very finality of death in a way that feels both liberating and terrifying. Now, a humorous but also very serious challenge to the idea of an infinitely vast universe, like in Level 1, is known as the Boltzmann brain problem. If you have an infinite universe, and given enough time, any possible arrangement of atoms will eventually spontaneously appear, then it becomes statistically more likely for a random collection of atoms to spontaneously form a disembodied brain that only thinks it's experiencing a universe, rather than for an entire universe to evolve into complex life forms. Imagine the sheer randomness of a boiling soup of particles. Every now and then, a collection of those particles might, by pure chance, briefly arrange themselves into a functioning brain that has memories and perceptions, even if it exists for only a fleeting moment before dissolving. The Boltzmann brain argument suggests that in an infinite, truly random universe, there would be vastly more of these randomly formed, disembodied brains than actual, complex, evolved observers like us. This would be a problem for the infinite universe idea, because if it were true, we would be far more likely to be a Boltzmann brain than a real person living in a real universe. This puzzle highlights the need for the multiverse theories to also explain why stable, complex, and evolving universes like ours are the dominant form, rather than just random, fleeting fluctuations. The very structure of our universe is built upon symmetries, properties that remain unchanged even when something is transformed. Think of a snowflake. It has a six-fold symmetry. In physics, fundamental laws often have symmetries, but sometimes these symmetries are broken as the universe cools or evolves. Imagine a perfect, symmetrical glass of water. As it freezes, the ice crystals that form break that perfect symmetry, creating a specific, structured pattern. In some multiverse theories, The different physical laws of different universes might arise from different ways that these fundamental symmetries were broken in their respective cosmic cooling processes. Each unique way a symmetry breaks could define a distinct set of cosmic rules for a new universe, contributing to the Level 2 diversity. Our universe is also governed by a strict cosmic speed limit, the speed of light. Nothing can travel faster than light through space. This fundamental speed limit plays a crucial role in maintaining the isolation of different universes or even distant regions within an infinite universe. Even if there are other bubble universes incredibly close to ours in some higher dimension, the speed of light ensures that information from them cannot bleed into ours, reinforcing their separate existence. It's a cosmic barrier, ensuring that our reality remains distinct, even if surrounded by an ocean of others. Beyond the scientific utility and explanatory power of these theories, there is an immense aesthetic value to the idea of a multiverse. It paints a picture of existence that is far grander, far more creative, and far more diverse than any single universe could ever be. It's a cosmic masterpiece with an infinite number of canvases, each displaying a unique and astonishing design. It elevates the universe from a single narrative to an epic, multi-volume saga, an endlessly unfolding story of cosmic potential. It invites us to appreciate not just the universe we inhabit, but the boundless, unimaginable tapestry of all that is and all that could ever be. Now, as we continue to journey through the theoretical realms, let's consider how the grandest of physics quests, the search for a theory of quantum gravity, might weave into the tapestry of the multiverse. Our current understanding of the universe relies on two main pillars: general relativity, which explains gravity and the very large-scale structure of the cosmos, and quantum mechanics, which describes the incredibly small world of particles and forces. These two mighty pillars, however, don't quite fit together perfectly, especially when we talk about extreme conditions, like the very beginning of the universe during the Big Bang, or inside black holes. Scientists are striving to find a unified theory, a theory of quantum gravity, that can seamlessly combine both. And here's where the multiverse often makes an appearance. Many of the leading candidates for a theory of quantum gravity, such as string theory or loop quantum gravity, naturally suggest the existence of extra dimensions or multiple universes. For example, in the extremely dense and hot conditions of the very early universe, where gravity was as strong as the other fundamental forces, the universe would have been governed by quantum gravity effects. The way these quantum gravity effects played out might have naturally led to the creation of not just our universe, but a whole host of others. Imagine the universe at its absolute infancy, a quantum foam where space-time itself is bubbling and fluctuating, with each fluctuation potentially giving birth to a new, distinct cosmic realm. It's like the very laws of reality were themselves in a quantum superposition, exploring all possible forms, and each possible form became a universe. This brings us to the profound idea that information might be the most fundamental building block of reality. In the Level 4 mathematical universe, every consistent mathematical structure is a universe. This elevates information from merely describing reality to being reality. Think about it. Our universe can be described by a vast amount of information, from the positions and movements of every particle to the values of every fundamental constant. If this information can be mathematically consistent, then it exists. This hints at a universe, or rather a multiverse, where information itself is the primal soup from which all physical reality emerges. It's a bit like living inside an incredibly intricate, self-consistent computer program, where the code itself is the ultimate reality. If information is truly fundamental, then the concept of a cosmic blueprint becomes even more intriguing. Is there a single, overarching meta-blueprint for the entire multiverse? Or is the multiverse simply a chaotic, spontaneous eruption of all possible consistent mathematical structures? This question delves into the very heart of causality and order. Some theories suggest a deeper order, a set of underlying principles that guide the formation of universes, even if the individual settings within each universe are random. Others lean towards pure randomness, a vast cosmic kaleidoscope where every possible pattern is eventually displayed, without any guiding hand. It's a debate that pits the elegance of order against the sheer power of infinite possibility. The human drive for exploration isn't limited to physical journeys across oceans or into space. It extends to the abstract realms of thought, to the very edge of theoretical physics. The exploration of the multiverse is, in many ways, an exploration of abstract space, a journey into the deepest mathematical and philosophical implications of existence. It pushes our intellectual boundaries, forcing us to invent new ways of thinking and new mathematical tools to grapple with concepts that defy our everyday intuition. It's a testament to the insatiable human desire to know, to understand, and to comprehend the universe in its entirety, however grand or strange that entirety may be. And perhaps, at its core, the multiverse answers the simplest question: why not? If the laws of physics as we understand them, even in their most fundamental and unified forms, allow for the possibility of multiple universes, then why wouldn't they exist? If the mathematical structures are consistent, if the quantum possibilities are real, if inflation is eternal, then the default assumption might shift from only one universe to a multitude of universes. It's a profound shift in perspective, moving from a universe of singular exceptionalism to one of statistical inevitability within an infinite cosmic landscape. This brings us to the endless quest. The journey into the multiverse is not a destination, but an ongoing voyage. It's a testament to the dynamic nature of science, where new discoveries and deeper theoretical insights constantly reshape our understanding of reality. We are like tiny mariners on a boundless cosmic ocean, constantly charting new territories of thought, always aware that beyond the horizon lies even more wonder, more mystery, and perhaps more realities than we can possibly imagine. The pursuit of the multiverse, whether confirmed or refined, promises to forever expand our understanding of what is real, what is possible, and what it means to be a conscious part of this astonishing existence. So, as we bring our cosmic journey through the multiverse to a gentle close, let's take a final moment to reflect on the profound shift in perspective these theories invite. For centuries, our understanding of the universe was beautifully confined to the single vast cosmos we inhabit. We marveled at its stars, its galaxies, its mysterious dark energy, and the incredible dance of its fundamental forces. But the ideas of the multiverse shatter that singularity, replacing it with a vision of boundless, unimaginable diversity. We've explored the subtle repetitions in an infinitely vast universe, where every possibility plays out countless times. We've imagined the frothing cosmic foam, perpetually bubbling off new realities, each with its own unique set of physical laws, a grand cosmic lottery where our universe won the prize of existence. We've grappled with the mind-bending idea of quantum reality, constantly splitting, creating infinite parallel versions of our lives, of every choice, every moment, unfolding in countless, unseen branches. And we've stretched our minds to consider a reality where every consistent mathematical structure is a universe, transforming existence itself into a vast, abstract library of all possible forms. This journey shows us that we are not just inhabitants of a single cosmos, but potentially tiny observers in an immense cosmic tapestry of all that is and all that could be. Our existence, our very physical form, is a product of these grand, often chaotic, and endlessly creative cosmic processes. The atoms that make up our bodies, the forces that bind them, the very consciousness that allows us to ponder these mysteries, all arise from the specific settings and conditions of our particular universe. And if the multiverse is real, then those settings, which appear so perfectly fine-tuned, are simply the result of an unimaginably vast number of other possibilities playing out elsewhere. It's a humbling thought, isn't it? To realize that our familiar reality might be just one note in an infinite symphony, one brushstroke in an endless masterpiece. But it is also an incredibly empowering thought. It means that the universe, or rather, the multiverse, is far grander, far more ingenious, and far more diverse than we ever conceived. It turns the cosmos from a single book into an infinite library, each volume holding a unique story, a unique set of laws, and perhaps unique forms of existence. We may never directly see or touch these other universes. They may forever remain beyond our cosmic horizon, mere whispers in the cosmic background, or elegant solutions within our most abstract mathematical theories. But the very act of contemplating them, of pushing the boundaries of our imagination and our scientific inquiry, enriches our understanding of our own place in this astonishing reality. It reminds us that the quest for knowledge is boundless, that the universe continues to hold secrets that defy our current comprehension, and that the greatest wonders are often found at the very edge of our perception. So, as we conclude this exploration, remember that the universe is always more intricate, more surprising, and more vast than we can ever fully grasp. The idea of the multiverse, in all its forms, is a testament to this unending mystery, a profound invitation to keep looking up, to keep wondering, and to keep imagining all the incredible possibilities that lie within the infinite embrace of existence.